Good. Okay, we are recording now. And I'll start sharing the screen and stuff like that. Okay. Now, I do want to emphasize also that this chapter is very calculator dependent. So you want to have your calculator ready and handy. Okay, so get my calculator ready. We'll be doing a lot of exponents. We'll be doing some logs also. Use the ln button from time to time. So ln and some exponents. Okay, I've got two kinds of calculators here that handle all cases, as I said before. This is a more fancy calculator. This is actually a graphing calculator where you can graph. You don't need a graphing calculator. And I also have a regular scientific calculator. Okay, so I'll be demonstrating as necessary. Okay, the other thing I needed to say is about the assignment. Now, the original sheet that I had said 5 to 12, but I'm noticing that in my book, it's actually changed to 7 to 14. That same kind of thing happened in 6.2, unfortunately. Okay, so I'm putting 7 to 14 odd if you're using my book. Okay, and I'm not even consistent with what I have because the last time I taught it was from a different edition. But like I said, it's all messed up because, you know, I can't go to City College and get the actual text. But frankly, the version of the book that you have shouldn't matter as long as you're doing equivalent types of problems. Okay, so the numbering that I have may not even match what I'm going to be giving you, but that's still going to be okay. Okay. Let's see. Can you mute yourself, please, whoever's out there? Okay, keep yourself muted, please. Hopefully we're all muted now. Okay, so schedule-wise, I'm already done with 6.1 and 6.2. Okay, so this is what I have planned for now. Again, I needed to gain a date, and I think I've already gained that date. Okay, back over here. So I'm pushing everything up a day. So I've already done 6.1 and 6.2. So this is our tentative schedule leading up to the next exam. Just think of pushing every date up. I don't want to write it the whole semester yet in case something else goes wrong. But the game plan right now is we're already up to 6.3 today, 6.4 Thursday. I won't give you a quiz today. I'll give you a quiz on Thursday. And the quiz on Thursday will be on 6.1 and 6.2 material, just so you know ahead of time. Okay, so on simple interest and compound interest. Okay, so the material that I'm covering today won't be on the quiz, nor Thursday's material. Okay, 6.4. Okay, the next Tuesday, 6.5, and then the next test on Thursday, the 18th. Okay, so this is the game plan for now. One section a day from here on out, and all the way through. Okay, assuming there's no more bumps or hiccups, just move everything up a day, and then I can move this up to here also. Okay, that's a tentative plan for now. Okay, so I'm already done with this. I'm already done with this. 6.3 today. I'll give you the formula. I'll do a few problems with it. Okay, same thing's going to happen with 6.4. 6.5, there's this big spreadsheet-looking thing that you need to have. And I'll be developing that kind of problem next Tuesday. And then that's all we need for the exam. Okay, so I'll review all of those things with you right now and show you all the formulas that you should have and put on your next cheat sheet, your next formula sheet. Okay, unless you feel like memorizing, which I don't think anybody wants to do. Okay. All right, so let's see. So again, next exam is the 18th. Okay, moving it up. And let's see, yeah, I think I'm caught up with what we have to do there. Okay. All right, so let me go back and review everything you want to have for the next exam. So there's no confusion. Okay, so 6.1. This should all be reviewed, so hopefully if you've been keeping up, you haven't fallen behind. All of this is just review. So 6.1, page 362 in my book again, which is the 11th edition. And I realize a lot of you have the 12th edition. There we are, 11th edition. So definitely put this on your formula sheet. It's on my page 362. And if you can't find it in your book, you can just watch the video. Interest is principal times rate times time. This is for simple interest. And I'll give you a problem in Thursday's quiz involving this. Okay, so principal is the amount that you deposit. R is an annual interest rate. When you punch it in your calculator, change it to a decimal. It's given as a percent, change it to a decimal, and time is in years. Then on my 363, future value of an investment. This one is not that hard of principal, an idea, I should say. Future value, S, is principal plus interest, P plus I. But we just said I was PRT, so P plus PRT. Same formula, S is P plus PRT. And if you do the algebra and factor out the P, it's also P times 1 plus RT. So this is simple interest. The question I'll be giving you on Thursday will be involving simple interest and compound interest. Okay, so just like before, at the end of class, I'll break you into your breakout groups of probably 3 or 4, and you work it together as a team. Everybody submits their own, but you put the names of everybody on your team, and I will grade just one person's paper, and all of you are going to get the same grade. So since you don't know who I'm going to grade, the only way you can be sure to get 5 points is for everybody to get it all correct, right? Okay, then what did I do last time? And then, by the way, you're saying, there's all these other formulas here. Yeah, you don't need them. Okay, so in the book, you say, where's all these other crazy formulas that are here? Yeah, we don't have to do them. We're not required to cover it, so I'm not. Okay, so don't even look at them. Then last time we did compound interest, 6.2. Okay, that would be my 369, I guess. And 371. The only one you really need is this one. S equals P times 1 plus I to the N. S is the future value. P is principal. I is the rate per compounding period. So you have to divide it by something, depending on if it says semi-annual, quarterly, monthly, stuff like that, right? And the N is the total number of compounding periods. Okay. So you multiply the number of years by the number of periods per year. Okay. So we did that last time. You're going to get practice with that again today. Okay. So that same concept applies today. That same concept applies Thursday, and that same concept applies next Tuesday also. Okay. So from here on out, the same concept for I. They give you an interest rate like 7%, 10%, whatever, and then it'll say compounded annually, semi-annually, quarterly, monthly. Then you know to divide by something. And then the N. Okay, you don't really need this. I mean, if you want to put it, you can, but you can survive with just that. S equals P times 1 plus I to the N. So this is for compound interest. Okay, so I'll give you a question on this on the quiz on Thursday also. So one question on simple interest, 6.1. One question on compound interest, 6.2. Okay. And now for the new stuff. And again, any formula you see in the book, say, hey, he didn't talk about it. That's right. You're not responsible for it. So you see there's other formulas like that one or whatever, or that one. Don't worry about it. Okay. So now what is 6.3 about? So 6.3 is in something called future value of an annuity. Page 383. And here's the formula that you need. It's on my page 384. Try to raise up the book here. Okay. S is future value. Don't even look at this. Pretend it's not even there. R is an amount that you deposit each period. So you say, is that like principal? Not really. Okay, and I'll explain why. you're making a periodic payment. Okay, so it's a regular payment. Okay, so S is equal to R, bracket, this great big fraction, 1 plus I to the n power minus 1, all divided by I. This is called future value of an ordinary annuity. I'll give you some background theory as to why it's used and when you use it and so on. But if you hear the words future value of an ordinary annuity, it means use this thing. Okay, by the way, problems that I give on a test tend to be in order. So in the test that we're having, again, the new date is 18th. Now, I tend to give 10 questions. So it looks like I'll give 2 from each, and in order. So you can pretty much bank on the first 2 questions are from 6.1. The next 2 questions are 6.2. The next 2 questions are 6.3, 6.4, and 6.5, and so on, okay? So you don't have to wonder, oh, which section am I in? Am I supposed to do this formula? It would just directly be in order, okay? Right, so get this formula down, put it on your cheat sheet. S is a future value. R is a periodic payment. Okay, R is deposited each period. 1 plus I to the n minus 1 all over I. This I is the same I as in section 2. It's a periodic interest rate. So if it says compounded semi-annually, divide by 2. Quarterly, divide by 4. Monthly, divide by 12. Okay. Annually, you don't divide by anything, you divide by 1. So, and that I is the same as that I. Okay, so whatever you have for here is the same as this. And n is the total number of compounding periods. Okay, so you take the number of years times the number of periods per year. So if it says quarterly, multiply by 4, the number of years. If it says semi-annually, take the number of years times 2. If it's monthly, take the number of years times 12, and so on. Okay? Now in the homework, they don't give you 365 because it's too clumsy, but that would be daily compounding, 365. Okay, so put this on your next cheat sheet. Okay, and planning ahead again, so I'm not going to talk on 6.4, obviously, but let me just show you what the formula is so you can start putting it down in case you haven't already done so. So page 393, something called present value of an ordinary annuity. Present value, AN, present value, cover that up. So AN is R. R is again a periodic payment. Periodic payment. And then a formula which is similar to the other one, but not quite the same. Bracket 1 minus 1 plus I to the negative n divided by I. Okay, so this is the formula that you want. Ignore that middle thing. A sub n is something called present value. R bracket 1 minus 1 plus I to the negative n divided by I. Okay, this is a periodic payment. I'll talk about some theory when you use it and so on. But that I and that n are the same. Please notice in this formula there's a negative there. So there's a negative exponent. Again, that I matches that I, but it's a slightly different formula. So little I, again, is a payment per period. Okay. So again, take the interest rate that they give you, semi-annual divide by 2, monthly divide by 12, quarterly divide by 4, annual don't divide by anything. And that n is the same. Okay. The number of years times number of periods per year. So if it says compounded monthly for 10 years, right? Then you go 10 times 12, which is 120. Okay. Or if it says semi-annual for 6 years, semi-annual means 2 times, so 6 times 2 would be 12, and so on. Okay. Now use that same formula for section 6.5. So 6.5, it's really the same formula. Now I'm going to hasten to add in 6.5. They show you a different formula. Whoops. Got so excited I knocked my computer off here. So I'll just mention for 6.5, which is on loans and amortization. To give you this other formula, you don't need it. It's equivalent to this one. Okay, in fact, that's the one we just had. They're giving you another one. You don't really need it. If you do a little bit of algebra on this, it ends up looking like this. In other words, these two are really the same, except they've isolated to R. Well, you don't really need it. Okay? You can solve for R in any event. Okay, so I'm not even going to give this to you. It's correct, And if you got nothing better to do and you want to write it, you may, but you can survive with just this. Okay. But the other really big thing you want to put on your cheat sheet again is this. Keep knocking my computer. Okay, so in my page 406, this table right here. Okay. So I'll hold this up just for a moment. I showed it to you last time. I'll probably show it to you next time and the time after that. But bring this exact example with you. Okay. This is sometimes called an amortization table or amortization schedule. If you were to take out a loan, car loan, home loan, or whatever, this is what you would see. Now, for most of the examples that we have, these are not realistic because there's only like 5. But this is just for teaching purposes. If you know how to do it after 5, you know how to do it after 360, which is typically what happens for a home loan, right? If you get a home loan, quite often it's a 30-year loan, compounded monthly. 30 times 12 is 360. So can you imagine having this thing all the way down to 360? Then, of course, you probably want to do it on a spreadsheet on a computer. Okay? But that's basically what happens. Car loans, well, I've seen car loans that are, what, 3 years, 4 years. 4 times 12 would be 48 if it's monthly. Okay. Here it's all paid off in 5. So I might make you make one of these things. Period, payment, interest, balance reduction, unpaid balance. Okay, so copy this, put it on your formula sheet. Okay. All right, so here we go back to the formula for today. I'll get started with some of the problems, and I'll give you some of the theory behind it. Future value of an ordinary annuity. Okay, so it is a kind of compound interest. Let me check the chat for a question. Okay, I'll get that a little bit later. Right. Yeah, anybody who joins a little bit late, yeah, just send me a chat or send me an email. Okay, what is happening here? Now, in the previous section, when we did compound interest, right? You've got a certain amount of money. So you go to the bank, plunk down, okay, banker, here is, I don't know, $20,000, right? So make my money grow. Okay, so there's terms. Okay, so here's the interest rate, and you're going to have it for so many years or whatever, right? So banker, here's my $20,000. I'm investing it for 7 years, and what are your terms? Okay, just say 8% compounded monthly or whatever, right? Okay, so you're depositing a large amount right at the beginning, but a lot of us maybe can't do something like that. You can't just plunk down a huge amount right away. Okay? What is much more reasonable is you make periodic payments, something called an annuity. Okay? I myself have an annuity. Okay, so rather than saying, oh, here is $50,000 and make it grow. Well, maybe you can't put down $50,000, but I can say, you can say, okay, I'll get paid every month. Maybe a lot of you get paid by the month. Okay, I can set aside $100, $200, whatever, and use that deposit, and I'll deposit that amount every single month or however frequently you want to do it. It could be every quarter, or it could be every year, or whatever. Okay, this is the formula that you use. Okay, so rather than plunking down a huge amount right at the beginning, you make periodic payments. Okay, so for an annuity like me, I subtract a certain amount from my paycheck every month, and I deposit that into the account. Okay, so let's say it's $100. Okay, so I've got my paycheck. Then every month, take out $100. Okay, it grows interest. Next month, take out $100, grows interest. Next month, take out $100, grows interest, and so on. Okay, so that's more usual. That's more easy to absorb than to just plunk down a huge amount at the beginning. Okay, so if that's the case, this is the formula that you use. Right, so if I were to keep doing that, right, so every month take out $100, $200, or maybe it's every quarter take out $250, or I can only do it every half a year, semi-annual, and I can take out $75 or whatever. Okay, and once again there'll be an interest rate. Okay, then after so many years, what's my new balance going to be? You see. Okay, so that's the strategy that we're employing right now. So rather than plunking down a big amount for Section 2 compound interest, it's almost like a regular compound interest. Okay, so every month for me, $100, make it grow. Then next month, another $100, make it grow. So next month, make it another and make it grow. Okay, so that's where this comes in. All right, so now let's get to the problems. Whoops, knocking all over my computer today. Okay, so for the assignment, okay, so I'm changing to 7 to 14 odd in my book. Okay. So let's look at number 8. So yeah, let me show it to you. For those of you that aren't planning to get the book, okay, so 390, you can just watch the video. So 7 through 14, so you should be able to see 7 through 11 here. 12, 13, 14, yeah, there we go. Okay. So number 8. On my paper it says 6 because it was a different edition, but it's the same problem. Okay, find the future value of an annuity of $5,000 paid at the end of each year for 10 years. If it earns 9% compounded annually. Okay, so the game we're playing is we're depositing $5,000 at the end of each year for 10 years. So year 1, $5,000. Year 2, $5,000. Year 3, $5,000. Notice this is different than last time, right? Last time we just plunked down a huge amount, don't make any other deposits, just make it grow. But no, this time it's $5,000 every year for 10 years, 9% compounded annually. Okay, now if it's compounded annually, what am I dividing by? Well, you're dividing by nothing, or you can say divide by 1 because n was 1, which means you keep the 9%. So the I is 0.09 and the n stays at 10. Okay, so here we go. Okay, so the R is $5,000, 10 years, 9% annual compounding. Okay, so annual compounding means I is 0.09 and n is 10. So I just throw it into the formula. Okay, you know, I probably should have written, let me go ahead and write the formula so I can always refer to it. So I don't have to keep looking back at the text. So S is equal to R times this great big fraction, 1 plus I to the n minus 1 over I. Put this on your formula sheet, your next cheat sheet. Okay, everybody please understand it's annual compounding, so you don't have to divide it by anything. So 5,000, 1.09 to the 10th power. Okay, since it's annual compounding, you leave that alone. Okay, n is 10, there's 10 periods. Okay, so we're making $5,000 deposits for 10 years. 1.09 to the 10th power minus 1 divided by 0.09. Okay, and 75,964.65 is the answer. Okay, so I'll hold it here just for a moment, and I'll try to show that to you on the calculator. Okay. Now, make sure you can do this on a calculator, and when you're doing this on a quiz or homework or the test, show me all of this stuff. I do give partial credit. So if you have all the key details down, say, oh yeah, you have this number, but this number just came out wrong. Maybe you just punch it in the calculator wrong. I could very easily punch it in the calculator wrong. Okay, but I see you have all the key ideas, then I can give you partial credit. Now, if all you show me is a number, I don't know your train of thought. So if you give me a number and it turns out to be wrong and I don't see any of this other stuff, what am I going to do, right? I have to give you 0. Okay, so show me, when in doubt, show me more rather than less, I guess is the way to say it. Okay, so let me see if I can punch this in the calculator, if I can find my calculator. Okay, if you have a calculator like this, it is possible to type it all in one fell swoop. So let me try 5,000 parentheses 1.09 exponent 10 minus 1 divided by 0.09. Okay, see if I can, whoops, sorry, line that up for you. Okay, 5,000, 1.09. My exponent button is this one. and it's being raised to the 10th power, subtract 1, and that should all be in parentheses, then divided by 0.09. Okay. 75,964.648. 648 means we rounded to 0.65, 65 cents. Okay. It's automatically wrong if it's money and you give, something digits past the penny. Right? You should not write 648, whatever. Our money doesn't go down that far, right? Our money in America goes out to 75,964.65. Stop there. Right? 648 means make it 65. Okay. Okay, the problem's done, but I'll dig deeper. What's the amount of the interest? And by the way, I may very well ask this on the quiz on Thursday. What's the new balance, but what's also interest? Okay. You can always find the interest by the difference between the old balance and the new balance, right? Okay. How much did I invest? Subtract that from what's the new value. Okay. Now, how much did I invest? $5,000 10 times. 5,000 times 10 is $50,000, right? First year, 5,000. Next year, 5,000. Next year, 5, right? For 10 years, 50,000. But what's the actual value of the investment? 75,964.65. That's the whole idea behind the investment, right? That's why you invest in the first place, is that your money would grow with compound interest. So the difference between the two, you subtract 75, blah, 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 divided by 50,000, that's considered interest. So you made 25,964.65 in interest under this scenario, okay? And yes, in case you're wondering, that is considered taxable income. So you would have to report that to the IRS and FTB, Franchise Tax Board, as income. Okay, so that's the whole idea behind investing in the first place, right? I deposited $50,000, 5,000 a year times 10 years, right? Okay. It's not $50,000 all at once, like last time, like section 2. It's 5,000 the first year, 5,000 the second year, 5,000 the third, right? So after 10 years, it's $50,000. Okay, so I put in 50,000, but now it's worth this much. Okay, so that's the whole idea. And so again, how do you find the interest? It's the difference between the new balance and the old balance, right? What's the worth right now minus how much did I invest? Okay, so that was annual interest, which is fairly straightforward. Now let's do a different compounding period, right? So number 10. Okay, number 10 there. Find a future value of an ordinary annuity of, am I doing the right thing? I'm not looking at the right thing, I think. Okay, find a future value of an ordinary annuity of $300 paid quarterly for 5 years. Interest rate is 12% compounded quarterly. Okay. And it looks like I did $3,000, which was what I saw in the previous edition, but anyway, that's fine. Let me just go with it. All right, we're investing $3,000 quarterly for 5 years. So every quarter, 3 months, I deposit $3,000. So every season, I guess, spring, summer, fall, winter. So maybe January 1, I deposit $3,000. And then 3 months later, April 1, $3,000. July 1, $3,000. October 1, $3,000. And keep doing that every quarter for 5 years. Okay? And it says you're earning 6% interest. Okay, so I take the 6%. Quarterly means divide by 4. 6% is 0.06 divided by 4. 0.015 is what goes in the formula. Okay, what's my N? 20. How'd I get that? 5 years, quarterly, 4 times a year. That was the same strategy last time. It will be the same strategy for Thursday's assignment. It'll be the same strategy for the Tuesday, a week from today also. Okay. Same concept. So these go into this formula now. Okay, so my I, so please understand you don't punch in 0.06. Where'd it go? Here, because that's 0.06 is divided by 4, 0.015. And the N isn't 5, it's 5 times 4 because it says quarterly. All right, so I'm depositing $3,000 every quarter, $3,000, and now I throw it into the formula. So 1 plus I is 1.015 to the 20th power minus 1 divided by 0.015. And I'll raise it up so focusing purposes. $69,371 it looks like. Now, you can put it all in one fell swoop if you wish. Okay. If you have a fancier calculator like this, you can. If you have only a regular scientific calculator like this, you might not be able to do it, so you might have to go slower. So let me see if I can demonstrate it for you folks. Okay, so for you folks who just have a regular scientific calculator, so I'd probably do this first. You have to go slow. Do this, take away 1, divide by that, and then times the 3,000. So let me try that for you. Okay, so I'm going to do 1.015 to the 20th power, 1.015. Okay, on this calculator, to get an exponent, you hit y to the x, this button right here. That's equivalent to this button, the up caret button, that one right there. All right, so hit exponent, and the exponent was what? 20. So 20. So right now I have that thing. That's just that. Then minus the 1. So minus 1. That's easy. Divide by 0.015. Divide, where's divide? Right up here. Divide 0.015. 0.015 divided by 0.015 equals. Okay. And then times 3,000. Times 3,000. So you can see it's a little bit clumsier if I don't have a calculator that can do all of this in one fell swoop. But anyway, there's the same answer. 69,371.001. 001 means just leave it as 00. So there we are. $69,371. Okay. And suppose I ask, what was the interest? I know it doesn't ask it here, but you want to know that. I mean, how much am I actually gaining out of doing this thing? So what's the amount of the investment? Okay, so again, in this scheme, $3,000 every quarter for 5 years. That's 20 times, right? So it's 3,000 times 20. So every year it's 3,000, 3,000, 3,000, 3,000. Next year, 3,000, 3,000, 3,000, 3,000. How come I'm saying 3,000 4 times? Because it says it's quarterly. Every quarter you make this deposit of $3,000. See? How many times total? 20. Because it's 5 years, 4 times a year. So 3,000 times 20 is 60,000. Okay? So I invested $60,000. Again, please notice this is different than Section 2. Section 2, you just make one lump sum deposit. That's it. No more deposits, no withdrawals. Just let it grow. Okay? This is an annuity. You make periodic payments. See, I can't put all that money down at one time. Okay? So, all right, this scenario, we deposit $3,000 every single quarter for 5 years. So that comes out to be $60,000 deposited. Okay? What's the new value? $69,371. That's the whole idea. Make my money grow. So how much is interest? The difference between these two, which as you can see is $93.71. Okay? I mean, that's the whole idea why you're putting this money down in the first place, so that it would grow and earn compound interest, right? So in this scenario, the interest is $9,371. And yeah, that would be considered taxable income again. You would have to report that to the IRS or Franchise Tax Board again. Okay. All right. I do see something in the chat, so let me go ahead and get that. All right, so that's fine. Yeah, anybody who joined late, yeah, just send me a chat or email me, and that's fine. This is all a different learning environment, you know, rather than just meeting on campus and we have internet connection. I think I told you last semester I lost a whole week because my internet was down for a whole week. So I couldn't teach for a whole week. So the students basically got a week vacation off of me. Not that I had wanted it, but that's the way it works. Okay. All right, so let me do the next one. Number 12, which I'm writing down as 10, same problem. A sinking fund, and you don't really have to worry about that expression. A sinking fund is established to discharge a debt of $80,000 in 10 years. If deposits are made at the end of each 6-month period and interest is paid at the rate of 8% compounded semi-annually, what is the amount of each deposit? Okay, in other words, you want the future worth to be $80,000. Okay, you have to make a big lump sum payment of $80,000 for some reason. Okay, pay off a debt, pay off a loan, a student loan, or whatever. That's why it's sometimes called a sinking fund. You got to earn a big amount, and then it just drops to zero because the son or daughter graduated from school or whatever, right? Okay. So in other words, this $80,000 does not represent the periodic payment, for which we're glad. You know, who's going to make 80,000 regular payments? Okay, but no, this is the left-hand side of the equation. It's the future value. And we're asking what is the amount of the regular payments that we have to make. Okay, and this is the kind of scheme that we're doing for the next section. So we're actually getting a jump start on a kind of a problem that'll be for Thursday and Tuesday. Okay, so again, we're not depositing 80,000. We want to make periodic payments so that it ends up growing to $80,000, right? So if I want to grow to $80,000, how much do I have to deposit? You see? Okay. All right, I don't have to show you the book anymore, but it was $80,000. That's the left-hand side of the formula. So 80,000 goes here. You're trying to figure out the R. Okay, 10 years, 8% compounded semi-annually. Okay, so that's what we want. So in 10 years, I want it to grow to $80,000. How much do I deposit each time? Semi-annually, so it'll grow to that amount. Okay, so semi-annual means divide by 2, twice a year. So January 1, July 1, something like that. Okay, so 8%, chop that into 2, that'll be 4% or 0.04. Okay, sorry, I messed up there. That's 0.04. I is 0.04. The N is 20. How did I get 20? 10 years, twice a year. You say, how do you know it's twice a year? It said semi-annual, right? So semi-annual, twice a year, 2 times 10 is 20. Throw it in the formula. Okay. And again, the 80,000 does not go here. 80,000 goes here. And again, most of the problems that we're going to be doing Thursday are like this. You'll be plugging in here and all this junk over here, and you're figuring out the R, periodic payment. Okay, so everybody okay on 8%? Semi-annual means divided by 2, 0.04. N is 20 because it's 10 years, 2 times a year. So here we go. 80,000 is R. 1.04 to the 20th minus 1 divided by 0.04. Okay. Okay, this comes out to be 29.778, blah, blah, blah. Okay, and let me just show you that on this calculator. So 1.04 to the 20th, punch that out, parentheses, 1.04 exponent 20 minus 1 divided by 0.04. 29.778, blah, 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 blah. Can you see that? And there's more. Okay, now, it's 80,000 equals 29.778 times R. How do I isolate the R? Divide by that 29.778 thing. Okay. Now, here's an important principle. Okay. I don't want to lose any accuracy at all. So you should not round this off. So I'm only putting 29.778 because I don't feel like writing all the digits. You don't feel like writing all the digits either. Okay. But for greatest accuracy, and this is what they actually do in banks and lending institutions, you keep every single digit. Okay. So you would have 29.77, can't even see it there. Whoops, sorry. 778078578. Okay. Now, some of you have a calculator button that says answer, ANS. Okay. Look on your calculator for a button that says ANS. Okay. If you have that button, great. It's going to be a little bit easier for you. If you don't have that button, you can still do the problem, but it's going to be a little bit worse for you. Okay. So look on your calculator. Do you have an answer button? Okay, I'll just go ahead and say, if you don't have the answer button, here's something that everybody can do. So to have the greatest accuracy, what would I do? I would divide both sides literally by 29.778078578. Okay. So in one way I could do the problem is to do 80,000 divided by, and then, sorry, you'd have to write this down maybe. You would lose, 15 seconds, I guess, compared to everybody else, 30 seconds, whatever. So the greatest accuracy is 80,000 divided by, and then you type in your calculator, 29.778078578. Okay. In fact, on this calculator, that's exactly what I would have to do. So I'll just go ahead and do it in this calculator. So this calculator, I'm forced to go 80,000, doesn't have the answer button, and then divided by, and then I have to type every single digit. So let me see if I can get it correctly. 29.778. Oops, I didn't even put the decimal point. So I messed up already. Start again. 80,000, 80000 divided by 29.778. So everybody can do this, by the way. 778,078, 5758, 5758. Very tedious. And there it is. 2686.54, 2686.54. So everybody can do that. Okay. So you could type all these digits out. Okay. But if you have the answer button inside the calculator's memory, it stores the last answer that you have. And you have a special button for it called answer. On my calculator, it's second function above this. So watch what happens here. I'm going to type, instead of 80,000 divided by typing all those numbers in that I did over here, 80,000 divided by answer, which is second function answer key. And look at what pops up on my calculator, 80,000 divided by answer. That means to the calculator, it's the same thing as if I typed in 29.778078578. That saves you a lot of typing, okay? And there's the same answer. See that? 2686.54. Okay, so once again, it's a nice key to have, the answer button right here. So look for that on your calculator, okay? If you have the answer button, then do just like I did, 80,000 divided by the answer. The last thing that you stored in memory was 29 point whatever. Okay, So 2686.54. Now, let me just show you what happens if you round off, you won't get the right answer. It'll be close, but you can probably tell it's not going to be exactly the same. So suppose I go 80000, and I divide that by, say, well, I'm lazy. I don't want to type in all those digits, right? I don't want to type in 29.77807855758. It'd be a little bit inaccurate. Suppose I just go 29778, right? You would have given 2686.55, rounded up. Very close, but not quite the same. Okay? You want accurate, you know, I want that extra penny, right? You owe me a penny, I want that cent. Okay? Of course, this is an exaggerated case, but sometimes if your numbers are really, really big, that small quote unquote difference might be, you know, quite a few dollars. Okay? So you'd have a slightly different answer. So the question for you is, do you have this answer button? If you have this answer button, it makes the work a lot easier. And this will happen next time also. If you don't have it, it's a little bit tougher for you folks, okay? Because if you only have a calculator like this, and sorry, you don't have the answer button, you folks would have literally had to type in, I showed you 80,000 divided by, then I typed 29.77807857858 for greatest accuracy. Okay. So there we go. Okay. Digging deeper again, what was the amount of my investment? So I invest this much semi-annually. How many times? 20 times. So every half a year deposit this for 20 years. So 2686.54 times 20. So the amount of my investment was $53,730.80. That's how much I deposited. But what's the new value? 80,000. Pretty good. So the interest is the difference between that and that. Okay, it looks like it's about $26,000 in interest. Not bad. Right? So I invested 53,000 plus. It's worth 80,000. Why? Because of the compound interest. Okay, which is the whole idea behind the investment in the first place. Okay, so again, if you have this answer button, it's great. It makes it a lot easier. And next time we'll be doing a lot more that involve the answer button. Okay. If you don't, sorry, it'll take you another half a minute or whatever, you know, to do what I showed you, all that. Okay, let me check the chat for somebody had there. Okay, and all that. Okay, all right, so I think we've caught up. Okay, so the next problem I want to show you, it's the last mean one. $14 is a little bit different. In fact, it's a little bit harder. $4,000 is deposited at the end of each half year in an account that earns 6.2% compounded semi-annually. Okay, there's semi-annual again, right? So you know what to do. Semi-annual, what should I do with that? Divided by 2. How long will it be before the account contains $120,000? So this is different. I have both money amounts. The amount that I'm depositing each time. Okay, so every half a year, 4,000. Okay, so 6 months, 4,000. 6 months, 4,000. 6 months, 4,000. How long will it be until I get to $120,000? Okay, so it's a different kind of game that we have going on here. Okay. So this time they give me the R, 4,000. They give me the S, the new amount, 120,000. This is the scenario where you're saying, okay, I want it to grow to a certain amount. I know how much I'm depositing. How long would it take for me to attain what I want? Okay. So 6% compounded semi-annually. We know what that means. Divide that by 2. So 6% is 0.062 divided by 2, 0.031. And we're trying to find N this time in the formula. Okay. So 120,000 goes here. 4,000 goes here. 0.031 goes right there. And right there, we're solving for n. That's different. Okay, so 120,000. You raise it up. Yeah, sorry, maybe I should raise this up again for focusing, in case you want to look at the video later and say it's out of focus and all that. Okay, so 120,000 equals 4,000. 120,000 goes here, 4,000 goes here. 0.031 goes there, and there's a 1.031 to the n power minus 1 divided by 0.031. Divide both sides by 4,000. Divide by 4,000, divide by 4,000. That cancels out. 120,000 divided by 4,000 comes out to be 30. So right now, looks like that. Okay, how do I get rid of the 0.031? Multiply both sides by 0.031. Use it up there. So these guys cancel out. That cancels out. 0.031 times 30, punch it in your machine, 0.93. So now the formula looks like this. 0.93 equals 1.031 to the n power minus 1. How do I get rid of minus 1? Add 1. Add 1 to both sides. Okay. So it looks like this now. 1.93 equals 1.031 to the nth power. Okay. That n is floating up there as an exponent. From the last exam, how do we get that n down? You take the natural log of both sides, which is the reason why we did problems like that before. We're going to need it now. Okay, so did you know logarithms are in financial math? Okay, that's why you have the ln button. Okay, a lot of financial situations, there's ln. Okay, so one more time, 1.93 is 1.031 to the nth power. How do I get that exponent down? You take the log of both sides, ln both sides. By doing that, that n gets to come down in front. So it now looks like ln 1.93 equals n times ln of 1.031. And you might not be able to see that. Divide both sides by ln 1.031. Okay, yeah, looks kind of funny there. Okay, so divide by natural log 1.031, divide by ln 1.031. So that cancels out. I rewrote it up above, so I'm going to show you what I have. I basically said n equals that, so I'll show that to you now. So n equals natural log 1.93 divided by natural log 1.031. Okay, and now you just punch it in the calculator. Okay, in case you're wondering, can I cancel out the ln's? No. If you try to do that divided by that, it won't be the same thing as this. You just have to do it basically. Okay, so I'll show you both calculators. So on this calculator, ln, what was it, 1.93 divided by ln parentheses 1.031. Where'd it go? ln 1.93 divided by ln 1.031. I put extra parentheses there also. 21.537, something like that. Okay. N represents periods, though. You can't have a fractional period. So you go up to 22 periods. Right? So 22 periods. And I'll show it to you for this calculator. You folks have to go backwards if you just have an ordinary calculator. So just experiment on your calculator. So you folks would have to go 1.93 ln. So 1.93, and then hit ln, which is here. Okay. Then divided by, so divided by 1.031 ln. Okay, 1.031, and then ln. Okay, so that's the denominator. And then I press equal. And there it is, 21.536, 21.54. which comes out to be 22 periods. But what's my final answer? Okay, the original question was how long, right? I can find that question is how long. So that normally means how many years. We have the answer as 22 periods. So we have to go back to the original problem. It said semi-annually, right? Twice a year. So if it's 22 periods, twice a year, that means I give my answer as 11 years. Okay, so under this scheme, I have to do it 11 years in order to gain what I want. So that's how I present my answer for this particular question. Okay, so that's all. That's the way it works. All right, folks, let's see. I'm done. What time is it? 5:40? Yeah, we have time left over. So if anybody has any question, you can ask it now. Otherwise, we're done. Just tell you where we're headed. Okay, so we're done with 6.3. Next time, 6.4. And at the end, I'll give you a quiz on 6.1 and 6.2 material. Okay, next Tuesday, 6.5. 6.5 is really the same formula as 6.4, except we have to do that amortization table, as we said before. Okay, and again, the test is going to be on from Thursday. So here's a little mini calendar now. Okay, so we're done with this. I should mark these off. So next time is this. I'll do 6.4, give you a quiz on 6.1, 6.2. Again, I'll break you up into your breakout groups and so forth. And 6.4, Tuesday, 6.5, test next Thursday on the 18th. And I told you all the formulas you want to put down. And you can put more. If you can fit more on your cheat sheet, then go ahead. Okay. Any questions? Because if not, we're done. Let me check the chat. There's nothing in the chat. So anybody want to unmute yourself and ask a question or put something in the chat? And if not, we're finished for the day. Okay, so anybody with a question, please? Okay, what page for homework? Okay, so it depends on which version of the book you have. Right, so I'll just say 6.3, 7 to 14. I don't want to say the page because it depends if you have the 11th edition or 12th edition and so on. Okay, but if you're going by my page, it was 390. And I projected it already, so you can get that in the video. Okay, so I think I've caught up there. Any other questions, please? Put it in the chat or unmute yourselves. I'll wait just a moment. Okay, I hear nothing and I don't see anything, so that means we're done, folks. So we will adjourn, and that'll be it for tonight. Okay, so we'll see everybody on Thursday, and have a good evening. Okay, good night, everybody. We'll see you next time.
Thank you.
Thank you. Bye.
Bye-bye.
Thank you.
Bye.
Thank you. Bye.